Continuing in college trig with 1.3, we're in the fourth video. 1.3D is in dog, and we're going to talk about quadrantal angles. A quadrantal angle is just an angle that's on one of our lines here. So we're starting here at our initial side. That's a quadrantal, and that. So it's a 90 degree, a 180, a 270, or a 0 or 360 degree angle. Okay, that's all it is. So what we're going to be doing here is finding the 6 trig functions for each of those angles. So if we are looking at a 90 degree angle and I want to find the sine, the cosine, the tangent, and then we've got cosecant, which is the inverse of that, the secant, inverse of that, and the cotangent, the inverse of that. So you're just going to flip them over to find the other 3. So let's just do the sine, cosine, and tangent right now. So the sine of a 90 degree angle is going to be, remember we always make a triangle. So if this were a 30 degree angle, this would go like this, and we'd have a triangle here. And sine would be the opposite over the hypotenuse, or the y value over the r value. Okay, so let's put y over r right there to find the sine. But we're not talking about a 30 degree angle, we're talking about a 90 degree angle. And look what happens here when we're talking about a 90 degree angle. We can't make a triangle out of that, can we? We can make a triangle out of an angle like 80. You know, it's getting real little. We can make one out of 89, but we can't make a triangle out of that 90 degree angle because it's a straight line. In fact, what happens is as this triangle, as this angle gets closer and closer to 90, what happens to this line here? It gets closer and closer to the hypotenuse. So for example, and this is sometimes take a little bit of going through before you kind of get it. So give me a chance here to kind of explain what's going on here. When we have a 30 degree angle, notice my y value and my hypotenuse are kind of far away from each other. But when I get into an angle that gets closer to 90, they start getting closer. And let's do this in blue. As I get closer to 90 here, my hypotenuse and my y value get even closer until they are on top of each other on a 90 degree angle. So what happens when they're on top of each other? That means the length of my r value, or my hypotenuse, and my length of my y value become the same. So it's an imaginary triangle because your hypotenuse and the length of your one of your sides can never be the same. But in theory, as it gets closer and closer to 90 degrees, the y value and the hypotenuse get closer and closer together. What happens to my x value? As I get closer and closer to a 90 degree, this is my x value here for this triangle. But for this triangle, see, it's getting smaller. And for the blue one, it's getting even smaller. Until these two lines, my hypotenuse and my y value, are on top of each other, what happens to my x value? It becomes 0. So when I do this on a 90 degree, my y and my r become equal. My x value turns into 0. So again, it's impossible because you can never have a length of 0 with a triangle. But in theory, that's what happens. So what is my y over r? My y over r would be, my y is going to be, and we're talking about a unit circle here, and a unit circle means that we've got this circle that the r is always equal to 1. The radius is 1. And that'll help when we do these. So if my radius is equal to 1 in these quadrantal triangles, or quadrantal angles, if my r is 1, what does my y have to be? My y also has to be 1, and my x is 0. So y is 1, r is 1. So my sine of 90 degrees is 1. Let's look at my cosine. My cosine is x over r. What did I say my x is? My x is 0. So this is going to be 0 over 1. So my cosine of 90 degrees is going to be 0. My tangent is y over x. What is my y? My y is 1. What is my x? My x is 0. Remember, whenever you have a number with a 0 in the denominator, it becomes undefined. So there is no tangent of 90 degrees. And you go ahead and do your cosecant, your secant, and your cotangent. So you take each of these three here and flip them upside down, or basically these here and flip them upside down, and you get your other three trig functions. So that's what happens when you do a 90-degree angle. If we were to do a 180-degree angle, we would have, okay, so for the 90 we are showing triangles like this, and as we got closer and closer to 90 degrees, our y value and our r value got closer and closer to the same until they were the same, and our x values became closer and closer to 0. As we moved from here to here to here, our x value gets smaller and smaller until it becomes 0. Okay, so that's what we did in the last one. So are you noticing here that everything is based on triangles, trigonometry? So whenever you have an angle or a line drawn from the origin, like that, you draw a triangle. You have a line here, you draw a triangle. You have a line over here and you're interested in this degree angle, you draw a triangle, because this degree angle will give you the same trig functions as this one here. Okay, so if we draw this triangle, we'll get the answer for that there. Alright, so any angle or any line they give you, you can make a triangle out of. So let's look at a 120-degree angle. So 120 starts here, there's 90, there's about 120. Okay, so we draw a line. So what do we do to draw a triangle? We draw a line straight down. It's always a line straight down, perpendicular to the x-axis. So if this is 120 degrees, this one is going to be 60. And we have our y, we have our x, and we have our r value. So in this case, the x is a negative number, the y is positive, and the r will always, always, always be positive. And we can then, at this point, find our trig functions to this triangle here, and it will also be the same as the trig functions of a 120-degree angle. So if I'm looking for the sine of 120 degrees, I can use this triangle right here in order to find that information. So again, you go 120 degrees, you draw your line through there like that, and then you just draw a line straight down and over. And that will be the triangle for the 120-degree angle. So if you take your calculator and just type in sine of 120 degrees, it will give you the right ratio. But if you want to find it by hand, you just go to 120, make your triangle, find your sine, which is going to be y over r, and you go from there. Alright, so let's say that instead of 120 degrees, we wanted 180. Alright, let's see what happens here. Let me get rid of, whoops, wrong way. Let me make this angle here, triangle, and then look what happens. We start making another triangle as we get this angle closer and closer to, so this is 120, and let's say that this is 140, 160, we get closer and closer to 180 degrees. What happens to our radius? it gets closer and closer to the same length of this side of this triangle here as the adjacent or as the x. So we're going to call that, this is my x value, this is my y value, and this is my r value. Now notice what happens as I get closer and closer to my 180 degrees. My r value starts getting closer and closer to the same length as my x value. And what happens to my y? It gets smaller and smaller and smaller until when r and x are on the same line, my y value turns into 0. Are you seeing how that happens? So let's look and see what happens here. So my x and my r become equal, and my y value turns into 0. So for 180 degrees, sine of 180 degrees, when I get to that, to where I'm sharing r and x are the same length and my y value becomes 0, the sine of 180 degrees is y over r, and y is 0, and we don't care what r is. Our answer to 180 degrees is going to be 0. Our cosine of 180 degrees is going to be, cosine would be adjacent, which would be x over r. Well, how long is our x value? We don't know, but we do know that x and r are the same number. So if x and r are the same number, any number over itself is going to be 1. But what is going on here is, if you'll notice, how long is x? It's going to be the same as r, but it's on the negative side. X is negative over here, so our answer is going to be -1 because my x is negative. My r is positive because r is always positive, like I said before, but my x is going in a negative direction here. So let's look at tangent. Tangent of 180. I don't care how long y is. I don't care how long x is. I know y at 180 degrees, though, is going to be 0, and it doesn't matter what x is. Our answer is going to be 0 for the tangent of 180 degrees. So you can do that for all of these. Let's say we jump to, see if I can get rid of all this stuff here. Let's say we jump to 270. So let's say that we're making angles and we're going to go all the way to 270 degrees. There's 270. So let's see what happens here. We've got that triangle. We also have this triangle, and let's just see what happens as we get closer and closer to this 270. Notice, again, that my y value, as I get closer and closer to 270, gets closer and closer to the r, the hypotenuse, the radius, until my y becomes the same as r in this, when it's on the line there, and my x value becomes 0. That being the case, I can find sine, cosine, tangent, cosecant, secant, and cotangent based on this bit of information. Okay? If you look at the table on page 24, it will show you, the table will give you all of the quadrantal angles, 0, 90, 180, 270, 360. And if you'll notice that the 0 degree and 360 degree are the exact same. So the only ones you really have to know are 0, 90, 180, and 270. Pretty soon you'll get to where you can do these in your head. And you don't even need the table. You don't need the graph to see this. You can see it in your head and actually do it. And I know that seems kind of impossible right now. But anyway, you will be able to do that. So let's end this video and go into some of the exercises.